Hey everyone, so today we're looking at another general solution from trigonometry, and this is how the question looks. It says determine the general solution of 3 sine 2x minus 2 cos 2x equals to 2 minus 2 cos squared x. Okay, so let's take it to the left and see what happens. Let's try and solve this. So the next thing we'll do is we will use double angle formula to change this to single angles. So, and we'll also do the same for the double angle here. We'll change this to its single angles. So this one becomes 2 sin x cos x, or cos x sin x, and then this one I will take an advantage because I see a positive 2 here and I want to eliminate it. So I want to create a positive 2 on the left hand side so that they will minus each other out and it will help me out. Okay, so I'll change this to 3 multiplied by 2 cos x sin x, and this one becomes 2 cos squared x minus 1. So that advantage I was talking about is that 2 here, it's negative. Multiplying with this negative 1 will create a positive 2. Had I chosen the other form of this double angle, I would still have a constant term when I simplify later, because they were going to be minus 2 and another minus 2, will still have a minus 4. I'm not saying that is not there. That's not possible to get to the answer if I go that route, but I saw that this could help me simplify this faster. So that's what I did. And then we took these two terms, we brought them to the left, and they become minus 2 and plus 2 cos squared x equals to 0. Next, we multiply the brackets away. We get 6 cos x sin x, and then here we'll get minus 4 cos squared x. Then here we get our positive 2. We still have a minus 2 and our minus 2 cos, a positive 2 cos squared x equals to 0. Then we see that these two will minus out, so they'll go away. And then this is plus 2 minus 4. This gives us minus 2 cos squared x. So this becomes that. And now here we have a nice factoring. We can have a common factor of cos 2 in both terms. So we'll take it out, and then we're left with 3 sin x minus cos x. Then here we have a product of two things giving us 0, which means one of them is 0. So either this is 0 or this bracket is 0. So 2 cos x equals to 0, or the bracket is equals to 0. Then dividing by 2 both sides, we end up with cos x equals to 0, and then we take cos x to the other side in this second equation. We get 3 sin x equals to cos x. Okay, let's move this to the top and continue with solving. So here what I'm going to do is I'm going to concentrate on the first equation, solve it, and then come back to the second equation and solve it separately. So this is what we end up with. This is cos x equals to 0, and it becomes arc cos. So we have a plus or minus arc cos of that number that we had here. And then arc cos of 0 is 90. So it means the x is equals to plus or minus 90 plus 360k. K is an element of integers. Okay. Now this can be written in a compact way, because if you think about it, from minus 90 to 90, it will be 180 degrees apart. So when we write out these answers separately and then we put them on the same, we plot the positive 90 and the negative 90 and all the additions of 360 multiples of integers, we will see that they points that we are talking about, or the x values we're talking about, will be 180 degrees apart. So it's simpler to write them simply as 90 plus 180. So this will span all the x values that both these two options here, the plus 90, 90 and then minus 90, are spanning. So this is the general solution from this. Next, let's go to the other one. So here we're going to manipulate this so that we end up with one trigonometric ratio on the left. So this is what we will do. We will divide by 3 both sides and divide by cos both sides. So we see that cos and cos will cancel, we'll be left with 1 over 3. And the 3's here cancel, we are left with sine over cos. Sine over cos is obviously tan theta, tan x, sorry. So now we have a simple equation. Then we will say x is equals to arctan of 1 over 3 plus the period of tan, where k is an integer. Period of tan multiplied by k, where k is an integer. So let's find a calculator and see what this is going to be. I was doing this earlier, so yes, let me just redo it. So this is arctan of 1 over 3. This becomes 18.43. So our answer is 18.43 degrees plus 180k. So these are both our general solutions for the equation that we started with. Okay. Now, to explain this a little bit more, or to verify this, we can use our graphing software, GeoGebra. What I did here is I have set up my GeoGebra so that on the x-axis it's reading degrees, and we have our y-axis simply as 1, 2, and 3, the normal integers. So what I did is, if you recall, the equation that we started with was saying 3 sine 2x minus 2 cos 2x. So I took this left hand side, made it a function. Then I took the right hand side, also made it another function. So I'm going to plot two functions on GeoGebra, and where they intersect will be all the points where the general solution that we solved for are going to be. So let's see if it's true. So I'll go back to the algebra view, and then this is my left hand side, our 3 sine 2x minus 2 cos 2x. So this is the function. This is how it looks. And then this is the right hand side. Okay. Now, starting with the first equation, where we ended up with cos x is equals to 0. The solutions that we got are the following. We got plus or minus 90. So this is the first point, and as you can see here, we have negative 90 at the intersection, and here's another point, it's another positive 90. So you see that they are 180 degrees apart. So when we add another 180, we'll get this one plus 360, which means we are going to 270, which is this point over here, as you can see here. Then if we take this one and add 360, we will be moving to 450, which is over here. This goes on forever, to the right and to the left. So as you can see, these points are exactly 180 degrees apart. So that hence the solution that we got of 90 plus 180k. So this is 90 plus integer multiples of 180, both to the right and to the left, and then we will get all these solutions. But those were not the only solutions to the equation that we solved. The other parts where these two functions are meeting are over here. Let's see what those values are. So here we have a point, and indeed it is 18.43, the one that we got using the equation that ended up with tan x is equals to 1 over 3. And then since it's 18.43 degrees plus 180k, it means every time we add another 180, we'll get another solution. And indeed, if you come here, we get another solution. And this is obviously 180 degrees away from this one. If we move even further to the right, we will find another point that is just after 360. So it's 18.43 degrees above 360 degrees. And this happens and it goes on forever. It even happens on the left hand side. From here, 180 to the left, we end up here. And all these values are all the values that we got by general solution. I hope this explains a lot about the general solution, why we call it a general solution, because it is giving us the answers for all the points where these two functions are going to intersect. All of them from here to the left, negative infinity and positive infinity. So these are the just some of the values that we can see or we can show. This continues forever. If we take it to the left, it continues like that forever. So I hope you enjoyed this lesson, and I hope it gave you clarity and you understand general solution even more. Please like and subscribe for more videos like this, and suggest in the comments below what I should do next, and I'll see you in the next one. Bye.